Hi, hello everyone. Welcome to this video. So last time we just cleared our screen, and for this time what I kind of want to do is just have like some triangle rendered, and for that we're going to have to get to know and to get familiar with the rendering pipeline. So let's just start up with rendering pipeline explanation on what it is, how it is assembled, and then we can jump back to our coding. Regarding pipeline, so this is how we can show pipeline. We have like a couple of stages. First one is input assembly. Here we just describe and pass data from the CPU to the GPU, but input assembly we're going to cover it in detail next time, so I'm not going to spend too much time here. So then we have the vertex shader stage, and that's the programmable part of the pipeline. What that means is, it means that we're actually writing shaders, and it does this. Let's say that we have this, and then we have like some points A, B, and C, and for each of those points, right, A, B, and C, vertex shader is going to be run, and it runs per point, like per vertex. So that's what it does. And here in vertex shader, we can actually move those points, right? If we do like some kind of transformation, we can rotate them around, and then we can scale as well, such that, for example, C ends up here, A ends up here, and B ends up here. So that's what it does. Let me just return this because I might use it for further drawing. Then the next part of the pipeline is primitive assembly. And here it's just saying primitive assembly, we can draw points, lines, and triangles. So it kind of defines that. So if we're drawing points, it's just this. If we draw lines, right, we can draw lines, but we can also like decide to draw triangles, and then that's it. Like, those are basic primitive types. Triangle is like the most complex one that you can get with graphics. Rasterization kind of triangulates that, right? It just prepares it for the fragment shader, and in the fragment shader is a really important one because it's also part of the programmable pipeline. It's also in DirectX, it's called pixel shader. So you can also think of it as a pixel shader. What it does is just kind of, once we have rasterized our triangle, right, we have it here, and then the fragment shader kicks in, and then it colors each of the pixels or fragments in here, right? And that's what the fragment shader does. In this video, we're just going to output single color, so our triangle is going to be red. And then we have like color blending part, and this one is a bit unusual, but we're going to cover it in bit detail more later on. So let's say that we have some shape, which is just a basic triangle, and let's say that it's filled actually. Can I fill it? Fill. Okay, cool. And then we have another shape. So the question is, what happens, right, if these two shapes intersect? So basically, the color blending has to answer if they have alpha, like what's going to happen with color, but it also, we can define like functions on how to blend those together, right? If a blue thingy right here is a source triangle, sorry, this is target, and the red thingy is a source, we need to like answer how to combine source and target. But we're also going to cover that in details because color blending, right, it's very important part of the pipeline. So that's it regarding the pipeline. Let's move forward. So to start with coding, we can just create a new sort of folder here, which I'm going to call pipelines, but let me see, just this is sort of wrong. Okay, so in headers we're going to have new filter, which is going to be called pipelines. And what I'm going to call this pipeline is just, it's going to be test pipeline, so maybe something like triangle test pipeline, something like that. So let's get with it, triangle test pipeline. And we're going to move this to pipelines. We can create a filter here as well in our sources, pipelines. So you can also call this render pipelines, that's fine as well. Why am I using pipeline? Because I got used to it with web GPU and this newer APIs where the whole pipeline is assembled. So while in DirectX11 you don't have code to code like that, you can actually abstract in a different way. I'm going to do it like this regardless. All right, let's see what we're going to need. So the pipeline is going to be very simple. We're just going to need our renderer in order to fetch like device and context. And we need some public methods. The first one is going to be, of course, constructor, sorry, test pipeline, and then we take the renderer in. Okay, I'm not sure what happened here. So we're just going to take render, but we can take it as a reference, right? We're always going to have it available. And then we're going to have some private method. The public one, of course, is going to be render as well, because we want to render stuff. Did we use camel case or Pascal case? Let me just see that, because I don't remember that. Okay, so we used Pascal case, so I'm going to try to like use this coding convention. Then we're going to have our renderer as a reference, right? So we're going to fetch this from the pipeline. So this is nothing new. We had our device, and then we also had device context. Of course, some folks prefer to use like this member device, but I'm just going to use it like this. Most of the stuff that we do is going to be somewhat simple. So no buffers, we don't need buffers. That's something that we're going to deal with next time, but we're going to need vertex shader, and then we're going to need pixel shader as well, right, in order to assemble our pipeline. All right, and these are programmable parts of the pipeline, so vertex and pixel shader, and then we can create a definition for this. But while we're here, we can also create our constructor right over here. And then we had our renderer. We can just assign it, and we're done here. Good. Next thing that I forgot that I want to have is just like some small method, which is going to be called create shaders. We're going to use this convention. So let's start with our shader. Before we start, I just want to create shader, right? We're going to need our shaders, and I'm going to do it under these filters, and then I'm just going to create shaders. But let's keep up with Pascal case, of course. I'm a bit used to camel case now. And then what we want to do is just create our vertex shader. So you go on the Visual C++, HLSO, and then we create our triangle vertex shader. That's all good, sort of. Just we're not going to take position in yet, so that we're going to do with next time, where we create buffers and then paste the data from the CPU to the GPU. For now, we're not doing that. We're just going to have vertex ID, and then HLSL, right? This shader language has a bunch of these built-ins, and one of them is vertex ID. Vertex ID is on the CPU when we say, like, for example, draw triangles, and so sorry, draw something, and then we pass number of points. For each of these points, this is going to be passed in, for example, 0, 1, 2. So I'm going to explain a bit later on as well. So for now, let's just code it, and then we can explain it. So we're going to draw triangle. So we need 3 positions, right, for our triangle edges or points of our triangle, and this is outside of the bounds of our viewer, basically. So this is really bad suggestion by Copilot, so not using this. We can say here top vertex, then we're going to have left vertex or right vertex, better, then 5. So this is right vertex, and then finally left vertex. And here minus 0.5, right, minus 0.5. And then we just return. What do we return? Float 4, right? We always have to return float 4 here. So it has a bunch of overloads, as you can see. For example, it can take float 2 and then the z and v as a separate parameters or as an undone vector. So here we can just say position, and then we use this vertex ID. here it's 0.f. We're not going to deal with that just yet. And then we can just say 0.1f here. So this component you always kind of want to leave at this 1.0. It's important because of transformations, right? In the future, we're going to be working with matrices, and then I'm going to come back with this, and it's also important for perspective divide. Also, we're going to mention it a bit in the future, but this is all we need for vertex shader, just to explain it a bit. So this is all very simple. Let's say we have our top vertex, right, somewhere over here. Let's say this is our screen. It's terrible screen, but all right. Then we have right vertex over here, right, minus, and our center is somewhere here. So this is like coordinate minus, sorry, 0.5, let's say, and then minus 0.5. Let's forget about this. And then we have this stage. And then in our rasterization stage, this is going to be created as a triangle. So this center is not very good, but let's imagine that center is here. And the way it works is on the CPU, we're going to have like some method which is called draw, right? And then we just pass to it number of points that we want to draw. And since points are here, so for each of these points, right, this, when we say 3, it's going to execute this shader 3 times. And this vertex ID is going to be 0, 1, and 2. So our 0 is over here, our 1 is over here, and our 2 is over here, right? Because here, right, we're using 0, but we have defined this as top. Then on the next one, we get 1 here, right? 1 pasted over here, but we're saying, okay, use this one, right? Over here, we're saying use this one, and then same for this, right? We paste 2, we use index 2 at the last one, and that's our left vertex. So you can define this in any order that you want. Kind of, because oftentimes you like have to decide, do you want to do your geometry clockwise or counterclockwise when drawing? It's kind of important. That's it regarding this part. So let's jump to our pixel shader, which is very simple because we're just going to output single color. So we need this, and then we're going to say triangle pixel shader. And these folders here in Visual Studio are not really folders, they're just kind of virtual folders. So just so that you're not confused by it. And here it's saying 0, 1, 1, 1, 1, 1. That's white color. So I'm just going to output red instead. So what is this saying? If we are drawing triangle, right, in our rasterization stage, we can decide, are we drawing points, lines, triangles? We're going to draw triangle. And what this does is for each pixel inside of triangle, this is going to be executed, and then it's going to paint it onto this color. In the future, we're going to be dealing with different colors. For now, this is just fine. So our pixel shader is very simple. Then we can start implementing our triangle test pipeline right over here. And here, what I want to have is, so we need to read these shaders somehow, and we're going to do that with a blob. So blob is just a binary of our shader code, and here we don't have DirectX11 equivalent, so we're going to use this. Then we're going to have vertex shader blob. Let's create another one immediately after this. And we can define pixel shader blob as well. Then we can have h result. And let me just see this. It already generated it. So what we're doing here is we're compiling that blob from a file. And our file, so we're going to need std string. And I'm just going to include string as well. So vertex shader is going to be our triangle, right? Yes, so, and then std string, our pixel shader. So let's just actually deal with vertex shader, then we're going to refactor this into one single method. And I'm just going to call this actually blob. And then shader as well. So here it says undefined. That's because we haven't included it yet. So was it included in our main, right? We included this over here, so we're just going to need pragma. We need another library, which is not this one. It's something like that. Let me see my notes. I have it somewhere. Okay, that's the compiler. So we need this. That's good. And then in our render, I guess, we can also include, where is our render? We can include that compiler header. Okay, here is good suggestion. So we just need to include that as well. And I think that will be it. And then we're good. So back to our triangle. So we have this. Here, this is not really good reading of a string, I guess. So we're just going to make this a bit better. So we can use, here you can see this LPCW string. So it kind of stands for long pointer constant to wide string. So you're just not confused with this. And then we can use it like this. And then we just converted this to wide string because it takes one string. So this is fine. We're not using any macros. Include standard file. That's okay. This parameter main function, we're just going to use main. So this main function has to correspond, right? If we go here to name of this function, just so that you know. Then our version. So we're compiling vertex shader and we're using 5.0. So yeah, there were like different versions of shaders depending on how DirectX has evolved. So we don't need no flags and no FX flag for now. And then we can just write our blob. And then this final thing is blob pointer. So we are actually going to create another blob. And we're going to call this error blob. So just in case there are errors in our shader, we can actually see what the errors are. And then if failed, and if we have our error blob, we kind of want to get message from it. And then let me see this. I'm just going to delete this. So if we have our error blob, we're going to do one thing. If not, we're just going to return some message. I also have this include stream. Now that we have this, let's just handle that error. So we can say if it failed, HR, and then if we have error blob, so this is good suggestion. We can say vertex shader failed, right? And then we need to include IO3 to use this C error. Then we're saying vertex shader compilation fail. We can just cast this buffer pointer to a string and then in line. If not, I'm going to remove actually all this stuff until here. We can just say our vertex shader compilation failed. And that's okay. Okay. So what I want to do is just move this to a separate function. And I'm going to create a small util class for it. So here I'm just going to say util. And we're going to have our blob util. Blob util. And then it's just going to have public. And it's going to be static method that returns our blob. And for that we need these headers. And using space, right? I did it, then blob. Good, we're going to need compiler, that's whatever. I think this is going to be fine for the most part. So just the name that I want to use, let me see. So we can just have create, or we can just name it create. And then we're going to need string. Sorry for this. I just want to organize this bit better so that it's easier to create both blob at the once. So we're going to have file path, then we're going to need version because we need to pass if it's either vertex shader or pixel shader, and then we need to pass the main method as well. So main function, but by default we're just going to always use main. Okay, let's create this one. So we can go here, create, and in our blob util. So let's just do this as well. New filter, util, and we're going to move this blob util here. Okay, so we're just going to go to our triangle test pipeline and move all of this right in our blob util. So we should have started with this from the get-go. So shader is not used. It's actually file path. We need other stream. This is all good. Just here we're passing main function, right? And here we're passing version. So is it a C string? I believe it is. All right, all done. So let's try to use this actually and see if we're going to get anything. So we're going to have two blobs. First of all, we're going to have home pointer. Oh, I did that then. Blob, vertex, shader, blob. And then we use blob util. We of course need to include it. I just did that. And then we hit create. So the name is triangle, yes, for vertex shader. And we don't even need to pass main because, as you remember, we set up default. So then we need not the pixel shader, it's fragment shader. I'm referring sometimes to this as a fragment shader because I'm used to WebGPU and OpenGL, but it's pixel shader. And then here it's PS, right, for pixel shader. So if everything went fine, we can already start using this just in our game. Right over here, after we create our renderer, we can create this triangle test pipeline. We include it, we create it, and then just in our constructor, we need to call this create shaders. Of course, we haven't created shaders, just blobs, but that's all right. So we can place it right over here. If we try to run it, let's see if we're going to get any errors. So here it's complaining. I guess the Visual Studio is trying to compile this, so we don't want to actually include this. So I'm just going to do this, exclude from project. But if you want to see them, you just like press this show all files. So they're excluded. I guess this filter is not necessary either. So let's just try to run it now. Still complaining. Create function must return a value. Okay, we just need to return blob here, and here we're just going to return null. And vertex shader blob is fine. So is pixel shader blob. I don't see any errors in my console, so all of that is good. So if I just try to introduce an error on purpose, let's see if that works. Let's just go to any four shaders, and I'm just going to do this. That's because I know that that won't compile, and as you can see, unrecognized identifier S. So it compiled them just fine. So similar to this, let's try to create a shader util class in our, I didn't remember this. So here in our util, right, we're just going to create a new class, and I'm going to call this shader util. I'm going to move it to util. Okay, so here what we're going to need, are these namespaces. One more using namespace, and then we're going to have public, and we're going to have two functions here. So one for vertex and the other for fragment shader. So here I did the 11. It doesn't recognize it because of course I forgot the namespace to the 11. And this is vertex shader. So create vertex shader. So we're going to need device here because we created from device. And the other argument is of course this blob that we have created earlier. Blob. And then I'm just going to copy paste this because it's very similar for the pixel shader as well. So I'm just going to call this pixel shader, and then we need to move this to pixel shader type. And here we're going to have this for the pixel shader as well. Let's just create it. This will be very similar. So we're just going to finish vertex shader and then just like try to move that to pixel shader as well. So we're going to have comp pointer, 11, vertex shader, and I'm just going to call this shader. And then very simple, we're going to have HR, and then we use device, right? We use this create vertex shader. So we need to paste the blob in that is pointer to blob because it's wrapped in comp pointer. We can get the buffer size here. That's the second argument. It needs to know how many bytes to read. Third parameters we can ignore, and then finally it sets our shader as a last parameter. So we just paste pointer to it. And then if failed HR, we just need some kind of error. And we can do this, fail to create a vertex shader. Right. I guess if something is wrong, our blob would complain with the vertex shader, so we don't need like some advanced error handling. So we're just going to do this, then copy, because the pixel shader is very similar. So we just need to change the type here, and then we're saying create pixel shader. And that's the only difference. So we have created the both. Finally, here we can set our vertex shader, and you can check the blob here, but I'm not going to do like some error handling. We have this shader util, so this is actually a good point, and I forgot to like assign our device here. But we don't have get device on our render, so let's just expose our device because we're going to need it. So here, home pointer, device, return device, this is fine. And then we also need one for the context. And then we can set it all right over here, our device and context, and then we can use it. So we can say here device. And the context we need in our render method. So let's just see if our vertex shader was created. It wasn't though. Let's see what the error is. Of course, error was for some reason device is here now. So let me just fix that real quickly. And it is now because I assigned it after the create shaders method. That's not going to work, of course. So I think it should be fine now. Okay, this is just on the debug symbol. Vertex shader is created, and so is pixel shader. That's good. The final step for us is just going to be to try to draw something. So for that, it's actually very simple. We just need our device context. That's why we fetched it. So we can draw, I didn't call it device context, I called it context. Maybe more appropriate name is device context, but whatever. So we have this method, and here is part where we assemble pipeline, right? We're saying what the vertex shader is, right? Or what the fragment shader is. We need to say what to draw. We're going to draw triangles. We need to say how many points do we want to draw. And in the future, we're going to paste buffers here as well. So right now we can just use it like this. We're just pasting the vertex shader, and then we don't need any special handling of this. Then we're going to say, here is your pixel shader. And then the next important part of the pipeline is what are we drawing? As you remember, I mentioned we can draw lines, points, triangles. We want to draw triangles. So we're going to use this set primitive topology. And then the flag is something like this, primitive topology triangle list. This is get. We need to set primitive topology. And then finally, out of context, we're just going to say draw. How many primitives do we have? Like 3 points. And then start location is from the 0 index. And just one final step here. We need to go into our game, and then we need here, where we typically render our objects. We can just call that render method. Let's try to run this. Nothing is shown, and I know why. It's just the one thing that I missed from the last time, and that can happen. Somewhere in our begin render method, in our render. So we need to set viewport as well. And for the viewport, we can just say const cd. These names are kinda unusual, but we have something like viewport. Here it is. So we need to set this viewport, and it's going to be 0 size. Then we had this frame buffer width, if you remember from the last time, and frame buffer height. And then we just need to use this context, right? And there is set viewports method, but of course we just kept one viewport, so we just paste in 1 for the number of viewports and then pointed to viewport. And here it's complaining because it's probably a float. That's good. Let's see now. And there we go. We have our triangle on the screen. So for this video, hopefully it wasn't too hard. This is where we'll stop, and then the next time we're actually going to cover how to paste data from the CPU to the GPU, because right now, if we take a look at our shader, which is right over here, this is hard-coded, so you don't want to use that, right? So this is just for our example, so that we can set something up, but in the next video, we're going to paste this in, and as well as colors. So we do that with buffers, but that's for the next time. For this time, just a quick recap. So hopefully you got all of this. Let me just bring this up, because this is probably the weirdest part, I would say. If I move this right over here, and then I need my marker tool. This might be confusing part. Right over here, when we're saying context draw, right, this tree, we're saying, okay, this shader, right, the vertex shader will execute exactly 3 times. And for this tree, it will pass the vertex ID 3 times. So it will be, it's 0, 1, and 2. And that's how this thing works, right? We paste 0, then in positions, we took this one, 1 and 2, and then we just outputted that as our vertex. So what does the vertex shader do once more? It just kind of draws the points, right? And then we had our rasterization stage, which kind of says, okay, let's create our triangle, and we set that right over here, right? This is controlling this rasterization stage, where we're saying draw triangles. You can also try list or points, and then we also have to set up vertex shader. And then after all of this, right, after this rasterization has run, then it executes the pixel shader, and in pixel shader we just output that single color for now. In the future it will be different kind of stuff, like textures, for example. And that's it. I guess this was important part. The compilation was done in our program, right, when we created this blob. But in the future, we can use external tool and then compile outside and then just take in the compile shader as well, so that we avoid this compiling of shaders when we run the program. Okay, that's it for this video. If you liked it, maybe leave a comment, subscribe, and for the next time, we're actually going to deal with buffers and how to pass data from the CPU to the GPU. Okay, that's it. See you next time.